Alright, guys, welcome to probability lesson 2. Today we're going to talk about experimental probability. So, this is a little different than yesterday. We're going to be doing yesterday's stuff and today's stuff in both the lesson and the homework, so it's important to know the difference. Remember, yesterday we called it theoretical probability. Today we're talking about experimental. So, in the word experimental is experiment. So, mostly there's going to be some experiment or some event happening that's already happening, and they've given us data already, and so we're able to calculate experimental probability. So I think you'll see these problems are worded a little different now, so I think it just requires a little bit of thinking or reading to know the difference. But experimental probability refers to the probability of an event occurring when an experiment was conducted. Okay, so there's going to be some sort of experiment or event happening, and we're going to talk about the probability within that event from the data that the event said. Okay. Let's see. So, example 1. Mr. Blursh flipped a coin 10 times. 3 of the times he got heads. Find the experimental and theoretical probabilities for his next flip. Well, I have to click this every time, which is annoying. Theoretical, that was all yesterday, right? So if you're just flipping a coin, for his next flip, what's the probability that you get a heads? Well, there's one event where you get a head, right? And there's 2 possible events. So the theoretical probability of getting a heads on the next flip is 1/2. That makes sense, right? 50-50. Experimental, however, deals with in the experiment. So the total number of times that he flipped a coin was 10 times. So that's the number of times this event happened. 3 of the times he got a heads, right? So in the experiment, 3 times he got a heads, and there's 10 total. So that would be your experimental probability of getting a heads. Within the experiment, he got 3 heads, and these are the total flips. Okay, so that's kind of experimental probability. It's different than theoretical. It doesn't have to be the same, right? If you flip 10 coins, if it's 50-50 theoretically, you should get 5 heads, 5 tails, right? But anyone who's flipped 10 coins knows that doesn't always happen, right? You can get 10 heads or 10 tails or 4 heads and 6 tails. There's so many different possibilities. So just because it's theoretical doesn't mean it has to happen that way, right? It's theoretically impossible to win the lottery, yet people do. So, um, theoretical doesn't always have to be what happens in the real world. And then same with experiment. Obviously, if I were to flip 10 coins right now, I shouldn't expect to get 3 heads. That's just in the experiment. What's the experimental probability, okay? So it's just based on their probability. So let's try this one. Again, making this when I was watching The Office, so gotta throw my Office reference in. I'm pretty sure it was season 2. Somewhere it referenced that he had 13 workers or coworkers. It wasn't clear if Michael was included, so I just said Michael has 12 coworkers. He randomly selects one coworker each day to prank. Of the past 20 days, he has picked on Pam 7 times. Calculate the experimental and theoretical probability that Pam gets picked on tomorrow. So, theoretical, again, that was yesterday's stuff. There's one Pam, right? So there's one favorable outcome where she gets picked on. And then we have to list all of Michael's coworkers that he's picking on, which there are 12 of. So that's the theoretical probability that tomorrow Pam gets pranked or picked on. Okay. Experimental now. Of the past 20 days, so 20 days, there's been 20 events, so to speak, where he picks on a coworker. He has picked on Pam 7 times. So the experimental probability would be 7 over 20. That's the times Pam got picked on, and that's the total number of days that Michael has been pranking in this experiment, quotation marks. Okay. One final example. A store has blue couches, black couches, and red couches. Of the past 5 customers, 3 bought black couches. Find the theoretical and experimental probability of the next customer buying a couch which is not black. So theoretical, not black. Now they don't tell us how many couches, but there's 3 different colors, right? There's 3 total colors. And how many different colors aren't black? Well, you have blue and you have red. So there's 2 events where the couch is not black, and there's 3 total colors. So the theoretical probability of the next customer not getting a black couch is 2/3. Experimental, however. So this requires a little bit of thought. Of the past 5 customers, so they're giving us the events that happened. They told us 5. 3 bought black couches. However, we want the experimental probability of not black. So if out of 5, we bought 3 black couches, how many of them weren't black? Well, that should be 2, right? Because if 5 people bought a couch and 3 are black, that means those other 2 can't be black, right? They have to be something else. So the experimental probability of not black is going to be 2/5. Okay? So that's the experimental probability the next person will not buy a black couch. They'll buy a different color black couch. Okay? So experimental, theoretical, very different. I don't think it requires a lot more work. Your homework, I believe, asks you for both theoretical and experimental. So make sure you got those nailed down. If you have questions, make sure to ask. Just know that experimental, it deals with the data from the experiment or the events that are happening. Okay, so in all these, there's been some event, picking on a coworker 20 times, or past 5 people buying couches, or short-term memory, Mr. Blursh flipping a coin 10 times. Okay, so there's some sort of experiment or event that's going on. So that's the difference. Because yesterday they didn't really give us any events. They just asked what's probability of doing this, probability of doing that. Okay, and so that's a theoretical. So again, ask questions if you have them. Otherwise, I'll see you guys tomorrow.